Hi guys, higher maths, trigonometric expressions, a wave function, the lesson 6D. So just another example of the wave function and how to do it. So you may have found after the first example you're a little bit, not quite sure about that, but hopefully after the second and the third ones, you're kind of getting your head around it. It is quite a repetitive process we're going through here. As long as we know the steps, we will be fine with this. It is a question that candidates score very, very well on in the final exam. So what's slightly different here? Well, we have thetas instead of x's, but that changes nothing. And we're going 0 is less than or equal to alpha, less than or equal to 2 pi. So rather than working in degrees, we will be working in radians this time. Now, this is a non-calculator question because there's going to be some exact value knowledge coming into it. Let's have a quick look at what it actually looks like. So again, it does look like a sine or cosine wave. The question asked us to write it in terms of sine, so it looks like a sine wave with an amplitude of 2 that's either been moved pi by 3 to the left or 5 pi by 3 to the right. So write it in the form r sine theta plus alpha. So again, expand using the addition formula, multiply through by r. And then to make life easier for yourself, rather than writing r sine theta cos alpha, write r cos alpha sine theta. Again, we're multiplying 3 terms together here, so we can reorder them. That's fine, because we want to be comparing how many sine thetas on either side. So here we have 1 sine theta on the left-hand side of the equal sign. We have r cos alpha sine thetas on the right-hand side for the equal sign. These must be equal, so r cos alpha equals 1. Cos thetas, we have root 3 cos theta here. We have r sine alpha cos theta on the right-hand side of the equal sign, so r sine alpha equals root 3. Next step. Calculate the value of r. So r squared will be 1 squared plus root 3 squared, which is 1 plus 3 square rooted. Square root of 4 is 2, so the value of r is 2. Again, we like that because we know the curve has an amplitude of 2, so that works out correctly. Tan of alpha, because it's alpha is the angle we're working out, will be r sine alpha over r cos alpha, which will be root 3 over 1. So tan alpha is positive, so we do need to check to see if we're looking in the first or the third quadrant here. How do we decide again? Well, we look at r cos alpha to find out cos alpha is positive. So answer must be in the first or the fourth quadrant. R sine alpha is root 3, so our answer must be in the first or the second quadrant also. So that means overall it must be in the first quadrant. So the inverse tan of root 3 is 60 degrees or pi by 3 radians if we're working in radians, which we are. So we have alpha. So root 3 cos theta plus 2 sine theta equals r sine theta plus alpha equals 2 sine theta plus pi by 3. Again, what does that mean? It means that root 3 cos theta plus sine theta looks like 2 sine, so a sine curve with an amplitude of 2. There's also been moved pi by 3 radians to the left, which it has been dragged back to the left there. Okay, so we may need to sketch these in the final exam, but that is not part of this topic. We'll do this in the next topic, the functions and graphs topic, so you will get a little bit extra practice at the wave function in a couple of weeks' time. But if we know it's 2 sine theta plus pi by 3, we can draw a sine curve. We can stretch it to give it an amplitude of 2, and we can also move it pi by 3 radians to the left.